adding or subtracting with each other, I could actually split it out like that. Then also, yesterday we ended off with looking at how to integrate functions like that, okay, and that would be looking at ax plus b, how n plus 1 over n plus 1, and then after that the coefficient of a as well, okay, then after that plus c. So this was what we have covered yesterday, right? Okay, of course there are some that has conditions, so one of the most important conditions for these rules to apply, or rather the first and the first and the third rule to apply would be that n cannot be equals to -1. Okay, because we will be looking at it in, I think, 18.3 or something. Right, so today we will be looking at some problems, okay, some problem sums on how to make use of the integrals. Okay, so basically in differentiation we were looking at differentiating to get the equations of the tangents, of the normals and all that. So in integrals, okay, we will be looking at the other way round. So maybe you will be given the derivative itself, okay, the equation of a normal and all that. Okay, so how do we get back the original equation of the curve? Okay, we may not be able to get back the exact original, alright, but we may be able to get back a certain range of possibilities because of the the constant that we have over here, which opens up that diversity over there. Alright, so let's look at try 7. Okay, we are given that the gradient of a curve at any point xy would actually obey this expression over here, 2x minus 1 cubed. Okay, because we know that dy over dx is the gradient, so this is the equation that we have. And furthermore, the curve cuts the y-axis at 0, 3, and we want to find the equation of the curve. Okay. So since we are given that the gradient at any point, okay, actually goes by this equation, so therefore we could actually do the reverse to get back the equation of the curve by integrating. So we could integrate. Why is this there? In integrating that with respect to x, we will be able to get the equation of the curve. And that will be 1 over 8 times 2x minus 1 to the power of 4 plus c. So this is not the exact equation of the curve. Okay, we are given that whole range of possibility because of the plus c over here, which is a constant. So it could be a plus 1, plus 2, plus 0.1, plus 0.99, we never know. Okay, but alright, we can find out what is the exact equation because of this second condition that we have over here, whereby the curve cuts the y-axis at 0, 3. Okay, so at 0, 3 itself, that means that your y coordinate will be 3 and your x coordinate will be 0. And then we can find out what is the exact value of c. And c will be 2 and 7 over 8. Okay, so therefore the equation of the curve please submit the power to see the signature. Okay? Any questions? So now confirm. dy over dx is directly proportional to x squared minus 1. And then after that, when x is equals to 2, we know that the y coordinate will be 3. And then also the gradient at that point will be equals to 9. So find y when x equals to 3. Okay, so we need to find out what is the exact equation of y so that we can sub in the x equals to 3 and then find out the coordinates. Okay, so given that dy over dx is directly proportional to x squared minus 1, how do you make use of this information? Y equals to kx. Huh? Jenny, what do you say? dy over dx equals to k x squared minus 1 with the brackets. Okay, so because it's directly proportional, so we know that there's a constant. Okay, so then after that, we have this second piece of information. Okay, so we can find out when x equals to 2. We know that dy over dx is 9. And we find that k is equals to 3. Right? So, sorry, k is equals to 3. So therefore, we can find the exact expression for the gradient. Okay, we need to actually find out what is the value of k first before we can proceed to integrate. Alright, so integrating this, we will get x cubed minus 3x plus c. Then we need to find out what is the exact value of c to know what is the exact equation. Therefore, we find that the equation of the curve, right, would be y equals to x cubed minus 3x plus 1. And not forgetting what the question wants when x is equals to 3. Any questions here? Because you find that k is 3. Do you know how the k comes from? Because direct proportional. So k is equals to 3. You all need to work out your brain a bit. Try 9, I think you all can do it on your own. Okay, do try 9 yourself now. These are all functions. a function of y in terms of x. Find a, the expression. Instead of y, you see. Okay, do we get an answer? A equals to x minus 1 bracket plus 2.
It looks so small, it's not like okay.
Expand x minus 1 square, huh? But we already learned the way to integrate. Yeah, like
We need time sheet.
I mean, there's nothing wrong as long as you integrate properly. Yeah. But it's a bit unnecessary lah. Okay. Okay, move on. Let's look at exercise 18.1, question 17. Okay, we are given that there is a curve for which the second derivative has this expression. Okay? And then after that, the curve has points 0, 3 and negative 1, 0. Okay? So we want to find out the equation of the curve. Okay, what do you recommend that we do first in this case?
So it's like 6x times 16.
6x minus 16.
Oh.
Can you integrate twice?
Why can't we integrate twice?
Can you?
Add together at one go?
No, integrate once and then integrate again.
Yeah lah, that's what we should do, right? Yeah, because if we integrate once, what will we be getting?
The first
derivative, right? So okay, we integrate once first. So integrating this, you will be getting. Sorry, you're saying something? How do you integrate a constant?
Or the CX.
You guys integrate any constant with the CX plus. Oh no, you don't use the plus again. Okay, so after that, over here we want to integrate another ones, okay, because we want to find the equation of the curve, which is y equals to something, right? So we will integrate this again. Okay, so c is just a constant, right? If you think about it as a constant 2 and all that, okay, integrating c itself will just give you cx. Okay, do you think that presentation-wise this will be ideal?
No.
Why not?
Because maybe the two constants are not the same.
Very good. So what do you think we should do then?
Plus d.
Plus d lor. Okay, so we just change another constant because we cannot assume that both constants are the same. Okay. Okay, but is this the end of the question? What do we have to do next? We have to find C and D, right? So we have to make use of the 2 points that we are given. Find out what is C and D. Okay, so when x is equals to 0, all these 3 terms will become 0. So basically D is equals to 3. And then at negative 1, 0, therefore the equation would be x cubed minus 8x squared minus 6x plus 3. What intermediate set? This one. And now. I rather not. Because
3x squared.
I realize you are very good at calculations. What does plus? Huh? Yeah, I rather not use that. Generally for the A maths you all did fine, you all did okay, just that a lot of careless mistakes. I don't know, O2 and O3 haven't key. On to question 22. We are given that at any point on the curve, okay, so the curve has this function y equals to 5x. So this is for the curve. Sorry, not 5x, fx. Okay, then after that, the second derivative will have the equation 1 minus x squared. Okay, the equation of the tangent to the curve at 1, 4 will go by this equation. Okay, so to illustrate this, so maybe we have some form, some curve itself. Okay, we have the point 1, 4. Maybe illustrate it more accurately, maybe something like that. Okay, 1, 4, and then the equation of this tangent. Sorry, my tangent is not well drawn. Okay, we'll have this equation y equals to 5 minus x. Okay, so we want to find the equation of the curve. Right? What will you all do first?
Find dy dx.
Okay, find dy over dx. So how do we find dy over dx?
Integrate the 1 minus x squared.
Okay.
Then this will be equals to 1.
This is equals to 1.
Negative 1.
Negative 1. Why do you say that?
Because the gradient of the tangent is negative 1.
Okay, very good. So the gradient of this tangent itself will be negative 1. Okay, and this tangent, this gradient value is happening when x is equals to 1. Okay, so at the point 1, 4, we know that the gradient of tangent is negative 1. So in other words, using this one that we have over here, we would be able to find out what is the value of C. So C is equals to negative 5 over 3. Then after that, we find the C already, so our first derivative would be going by this equation, and then we will be able to find out the equation of the curve, right? By integrating it again. Okay, so at this point, although there's no C, I'll recommend that you use a D instead of a C. Okay, so as to not cause any confusion with whatever you have used earlier. Okay, so even if there's some equation of a line, you use y equals mx plus c. Okay, just make sure that you are consistent in your working. There is no contradiction in representation. Okay. So we need to find out what's the value of d. So when at the point 1, 4.
The first derivative cannot actually
Why you touch 3 draw? Then the 3 go where? 3 times of derivative, first derivative. But you don't know the value. You cannot just eliminate 3. Right, any questions? One last problem sum before I call it a day. Alright, in question 23, we have the gradient of the curve to be kx plus c. K and c are constants. The curve has also a stationary point at 2, -3. We have no idea what kind of stationary point that is, but it may not be important. Okay, and then also the curve cuts the y-axis at the point 0, 1. Okay, so we want to find out what is the equation of the curve. Okay, so since we know that in the first line, that the gradient of the curve is kx plus c, so let's just form that out first. We know that dy over dx would go by kx plus c. Correct? Okay. Then what else could we do? If I were to go on to directly integrate, okay, I think it might be a bit confusing. Right? Or you want to continue doing this? Huh? At this point, what is equals to 0? dy over dx equals to 0. Okay, if you were to if you were to jump straight into integrating it, okay, you will find that there are 3 constants. It might be a bit difficult to actually go on to actually solve for these constants. Okay, so directly integrating might not actually be very ideal. Okay, so we make use of the point 2, -3, and also the fact that it's a stationary point. Okay, we know that dy over dx would actually be equal to 0. Sorry, actually you can just directly integrate it. Because we still have to push. Okay, so we got c equals to -2k. Then after that we will integrate it, right? I'm sorry. Okay, then we get this. Right? Then after what can we do?
Sub in the
Okay, at 0, 1, sure. This is just 0, right? So we know that d is equals to 1. So up to here, that means that we will be getting this. Right? Then what could we submit? 2, negative 3. Yeah. I want to jump step. Okay, so sub 1 is 2. So therefore y would be equals to 2x squared over 2 plus negative 4x plus 1. So y is equals to x squared minus 4x plus 1. Okay? Equation of the tangent at 0, 1. Okay, so we know that the gradient will be kx plus c, which is 2x plus minus 4. Okay, so at the point 0, 1, your gradient will be equals to negative 4. So equation of tangent y minus v1 equals to negative 4x minus 1. So y is equals to negative 4x plus 1.
second part.